9. Stoichiometry. Stoichiometry is converting between amounts in chemical equations. It allows us to predict how much reactant we need to produce a certain amount of product and how much product we can expect using a certain amount of reactant. So when you interpret a balanced equation, we have the coefficients, for example in this reaction, 1, 3, 2, and so there's several things we know about the amounts of these reactants and products based on the coefficients. With words, we would read this as nitrogen gas reacts with hydrogen gas to produce nitrogen trihydride, also known as ammonia gas. So with moles, the coefficients in the balanced equation tell us the number of moles of reactants and products. So because there's a coefficient of 1 here, there is 1 mole of nitrogen, which reacts with 3 moles of hydrogen to produce 2 moles of ammonia. With volume in liters for gases at STP, the coefficients tell us how many liters of gas are involved as reactants and products. So what you do is you take this coefficient and you multiply it times 22.4 liters for each gas in the equation. For example, this would be 1 times 22.4. This would be 3 times 22.4 for hydrogen, and then it would be 2 times 22.4 for ammonia, and these would all be liters. If I wanted to describe the representative particles, I can use the coefficients times Avogadro's number, 6.02 to the 10 to the 23rd. So for nitrogen, it's 1 times Avogadro's number worth of nitrogen molecules, reacts with 3 times Avogadro's number worth of molecules of hydrogen to produce 2 times Avogadro's number worth of molecules of ammonia. And so all of these would be molecules for their unit. Finally, we can describe each with masses. The total mass of reactants must equal the total mass of products. You can get the molar mass of each reactant and product by adding them up from the periodic table. And then we're going to multiply each mass by the coefficient in the balanced equation. So here are the masses of nitrogen, hydrogen, and ammonia from the periodic table when we add them up. So these are the molar masses. And so to describe the mass of each reactant and product, I will take the coefficient and multiply it times its molar mass from the periodic table. Remember, grams per mole represents molar mass. And then, this is for nitrogen, it reacts with 3 times the molar mass of hydrogen from the periodic table for hydrogen to produce, and then for ammonia, we'll take the coefficient 2 times its molar mass from the periodic table, 17.04 grams per mole. So if you'll notice, so FYI, notice that the coefficients 1, 3, and 2 only represent the number of moles. It does not represent the number of liters, molecules, or grams, because the coefficients get multiplied by the molar volume, Avogadro's number, or the molar mass. So the coefficients only represent the mole ratio in a reaction. First, let's look at the rules on how to set up these problems. We're going to put our given and our unknown information in above the equation. So you're going to draw out line equals line. And on the left-hand side of that is going to be where you put your given information. So it's going to be a number and a unit. And on the right side of the equation is where we put the unknown information. And that's going to also be a number and a unit. On the bottom of the equation, we're going to use the coefficients from the equation to write the amounts below the equation. So you're going to write your coefficient here times some information, and then same thing on this side, the coefficient times some information. Now, what is this information in the parentheses? It's going to depend. Whatever unit this is up here is going to tell you whether or not you're going to choose to put 1 mole, 6.02 times 10 to the 23rd, 22.4 liters, or molar mass, which is grams from the periodic table. And that's going to be the same thing over here. Whatever the unit is here, the unknown, what we desire, is going to be 1 mole or 6.02 times 10 to the 23rd. And this is going to be atoms, molecules, formula units, etc. And then 22.4 liters or molar mass, which if you don't recall is grams, and we get it from the periodic table. So whatever you have unit up here, that's going to tell you which of these to put in the parentheses at the bottom. Same thing on the right-hand side. We're going to multiply it by the coefficient from our balanced equation. So you want to choose the one that matches the respective numerator unit up here. So whatever unit's here is going to be which one of these you're going to put in the parentheses at the bottom. So let's see an example problem. This is our balanced equation. So that means that my coefficients are going to be 4, 1, and 2 for each of these compounds, sodium, oxygen, and sodium oxide. So now let's look in the problem and locate our given. And here it is, 5.00 moles of sodium. You have to identify not only the number of your given, but the unit and of what is it, because that's going to tell you which coefficient we're going to use in the equation as well. Now let's identify what is our unknown. And here it says calculate the number of moles of sodium oxide, or Na2O. So this is my unknown. That's the question right there. So we're going to set up our proportion now. Here is our proportion. We're going to put our given here, which is 5.00 moles of sodium. That's our given right there. And then our unknown is over here, and we're going to say X moles of sodium oxide. That is our unknown right here, X, because we don't know what it is. Now we're going to set up the bottom, and remember that whatever unit you have on top is going to have to match the unit at the bottom. So first let's put our coefficient. Sodium has a coefficient of 4, and sodium oxide has a coefficient of 2. Times. Since we have moles in the numerators, we want to choose 1 mole to be in the bottom in the parentheses. And that's going to be for both of them, because that's mole, so we'll put 1 mole here, and because that says mole, we're going to put 1 mole here. Now we're going to do some math to solve for our X, which is right here. So we're going to do some cross multiplying, which means we're going to take this times this, 5.00 times 2 equals this times this. So it's going to be the 4 times the X, which gives us 4X. And now we're going to solve for X. Of course, 5 times 2 is 10 equals 4X. And then we're going to divide both sides by 4 in order to get X is equal to 2.5. And this is going to have this unit here of our final answers. That's 2.5 moles of sodium oxide is our final answer. So this should be 2.5 moles of sodium oxide. Let's try the next example. First, let's identify what is our given. And our given is going to be this, 3.2 moles of potassium chlorate. And which one of these is potassium chlorate? That's going to be this one right here. And notice it has a coefficient of 2. Now, what is our unknown? How many moles of oxygen is our unknown? And that's going to be this in our equation, which has a coefficient of 3. So now we're going to set up our proportion. Our given is 3.2 moles of KClO3, and our unknown is X moles of oxygen, which remember it's a diatomic, so it's O2. At the bottom, I'm going to put my coefficients. So for KClO3, the coefficient is 2, and for oxygen, the coefficient is 3 times. And now, what are we going to put in these parentheses? Well, whatever your unit is in your numerator tells you what to choose in your denominator. And so we're going to choose moles because both of these have moles in their numerator. So we're going to put 1 mole and 1 mole in the parentheses in the denominator. Now we're going to cross multiply this in order to solve for it. So to cross multiply, first we're going to have this times this. That's 3.2 times 3 times 1, which is 3. And then equals, and now we'll do this times this. 2 times 1 is 2. And then 2 times x is 2x. And so now we can solve this proportion. 3 times 3.2 is 9.6 equals 2x. So we just simplified these by multiplying them. Now I'm going to solve for x by dividing both sides by 2. And then that's going to give us x is equal to 9.6 divided by 2, which is 4.8. Remember, that is of this right here. That's our unknown. So it's 4.8 moles of oxygen. Let's try our next one. Our given in the problem is 15.0 moles of oxygen. And that's going to be this in our equation. And notice it has a coefficient of 1. When you don't see a coefficient, it's automatically a 1. The unknown in our problem says how many moles of water. So moles of water is our unknown, and that's going to be this one right here. Notice it has a coefficient of 4. So now we can set up our proportion. Put our given on this side, 15.0 moles of oxygen and x moles of H2O. Now, the coefficients for oxygen, it's a 1. So we're going to put 1 times. And then over here for water, the coefficient is 4. So 4 times. Remember, whatever unit is up here is going to tell us which of these I have to choose down here. So since we have moles at the top, we're going to choose 1 mole for both of these because they're both 1 mole. So we're going to put 1 mole here and 1 mole here. Now, in order to solve this, we're going to cross multiply. So it's going to be this times this, 15.0 times 4 times 1, which is just 4. So this is going to be 15.0 times 4 equals this times this, which 1 times 1 is just 1, and then 1 times x is just x. So in this case, 15 times 4 is going to be equal to our x. So x is going to equal 60. Remember, this is the unit of our answer, so it's going to be 60 moles of H2O. In this one, identify your given. 2.9 moles of N2H4 is our given. N2H4 is this right here, which has a coefficient of 1. Then our unknown is how many moles of N2. So that makes this our unknown, and it also has a coefficient of just 1. So now we can set up our proportion. So our given is 2.9 moles of N2H4, and our unknown is the x moles of N2. And then below, you're going to put the coefficient of 1 there and 1 there, because those are our coefficients in the equation. And then remember, the numbers at the bottom in the parentheses have to match. So since that says mole, I'm going to choose 1 mole to go at the bottom, and since the unknown is also moles, I'm going to choose 1 mole to go at the bottom. Now we can cross multiply these to solve for x. So it's going to be this times this. So 1 times 1 is just 1, and 1 times 2.9 is just 2.9. Equals this times this. 1 times 1 is 1, and 1 times x is just x. So here we already have our answer. X is equal to 2.9. Remember that this is what your answer is. So it's 2.9 moles of nitrogen, and that's our final answer.